Hello and welcome to this video on quadratic simultaneous equations. Now in the previous video we looked at linear simultaneous equations where there weren't any squares on the x or y. So it might have been a pair of equations like this, and we could make those y's cancel, for example, by just adding the two equations, because then you'd have y plus negative y, and they would cancel, and then you would just have a single equation in terms of x. And that was a process known as elimination, where we're trying to get rid of, eliminate one of the variables. In this case, we could eliminate y by adding the two equations together. Now, unfortunately, with these kind of simultaneous equations, that strategy doesn't work. We've got what we call linear equation here, and it's called linear because if we were to sketch this equation on an x and y axis, it would look like a straight line. Linear means straight line. And this is sort of a quadratic equation because you've got some powers of 2 in there, you've got some squares. Now the reason we can't use elimination in this case is that if we add the two equations or subtract them, we're not going to make any of the variables cancel. If you, for example, subtracted these, we've got a y term and a y squared term. They don't collect together in any way, so we can't possibly make those y's cancel. So we have to use another approach known as substitution. And the process is basically just this. Step 1 is to rearrange the linear equation to make x or y the subject. This will become clear when we do an example. And then step 2 is substitute this into the other equation and solve. So let's apply these particular steps on this example here. Now this is a linear equation, so we rearrange the linear equation to make x or y the subject. Well, y is already the subject, so we don't really need to do step 1. So step 2 is then substitute this into the other equation and solve. And what I mean by this is because we know that y is equal to x plus 1, it means we can replace any instance of y in the other equation with x plus 1. So that y there can be just replaced with x plus 1 because we know y is equal to x plus 1. So let's do that. We're going to say x squared, we still got x squared, plus, but this y here we can replace with, in brackets, x plus 1. So now we've got x plus 1 squared, and that is equal to 5. And now we've got a single equation in terms of x, a quadratic equation, which is why we call these quadratic simultaneous equations. And we can just solve this in the usual way. So we've got some brackets here, so let's expand those out. So we've got x squared plus, we do each thing in the first bracket times each in the second. So we've got x times x, which is x squared. We've got x times 1 and 1 times x. So we've got 1x plus 1x, which is 2x. So I kind of skipped a step there. And we've got 1 times 1. And that is equal to 5. Now what I'm going to do is I'm going to subtract 5 from both sides of the equation. Because do you remember, when we're solving a quadratic equation, we want to have 0 on one side of the equation. Now let's just collect like terms. We've got x squared plus x squared, which is 2x squared, plus 2x, and then we've got 1 minus 5, which is minus 4, equals 0. Now you might notice that all of these things divide by 2. They're all even. So we could just divide both sides of the equation by 2 to make the numbers smaller. So this gives us x squared, plus that just becomes x, because 2x divided by 2 is x, and that becomes minus 2. Now we want to factorise this quadratic, so we need two numbers which add to give 1 and times to give minus 2. Well, those numbers are 2 and minus 1, so we've got x plus 2 and x minus 1 is equal to 0. And then we've got the product of two things is equal to 0. So either this thing is 0, if x plus 2 is 0, then x is minus 2. Or if this thing is 0, if x minus 1 is 0, then x would have to be 1. Now, these are simultaneous equations after all, so for each value of x we find, we need to find a value of y. So if I just write up here, so we had x was minus 2, or x was 1, and then we can just substitute these back into one of these equations to work out what y is. Well, y is just x plus 1, isn't it? So y is this x value minus 2 plus 1, which is minus 1, and y is equal to x plus 1, 1 plus 1 would be 2. So we've got these two solutions. Now the reason we might do this is because we might be trying to find the intersection of two different lines. Now if we were to sketch y equals x plus 1, it would look like this line here. And if we were to sketch x squared plus y squared equals 5, that's actually the equation of a circle. X squared plus y squared equals r squared is a general equation of a circle with radius r. So in which case the radius would be root 5, but we cover that in another video where we sketch circles, but don't worry too much about that. But the point is, we've got a sketch of each of these two lines, and we saw in another video that if we wanted simultaneous equations graphically, we would draw the two different lines and find the points of intersection. So our solutions that we got here, well, if x is minus 2 and y is minus 1, that gives us the point minus 2, minus 1. So we'd have a point of intersection of these two lines at minus 2, minus 1, which is going to be there. And our other point of intersection was x is 1, y is 2, so we get the point 1, 2, which is going to be there. So that would correspond to the other point of intersection. Right, question 2. We've got y is equal to 2x squared and y is equal to 20 minus 3x. So if we look at our steps again, step 1, rearrange a linear equation to make x or y the subject. Well, this is a linear equation. Is x or y the subject? Well, yes it is. Y is already the subject. And then we can substitute this into the other equation and solve. So we look at the other equation, and it means we can replace the y, substitute the y, with 20 minus 3x. So we can write 20 minus 3x, we replace that y, is equal to 2x squared. So again, we have a quadratic equation, and we want to solve it. Remember, to solve a quadratic equation, we want 0 on one side. So we want to try and get everything on the side where x squared is positive, i.e. on the right-hand side. So what I'm going to do is I'm going to add 3x to both sides. So I have 2x squared plus 3x. And I also want to get rid of that 20 there. So I'm going to subtract 20, and that's just going to leave 0 here. We need to factorize this. Now I highly advise you watch my video about factorizing expressions where the coefficient of x squared is not 1. But I'm going to quickly do it now by just guessing the two brackets. But there is a method called splitting the middle term, which I won't do here. So to get the 2x squared, it's probably going to be the 2x times the x. We're thinking about what expands to give this. Now to get the minus 20, we need to think of two numbers here that times to give minus 20. But it's got to work with that plus 3x. Now I know we can use plus 4 here to get us up to 8x, and I'm going to do minus 5 here. So we have 8x minus 5x, which would be 3x, and minus 5 times 4 does give you minus 20. Now, we've got a product of two things is equal to 0. So if 2x minus 5 is equal to 0, then we have x equal to 5 over 2. Do you remember the quick way of doing it is you negate this number here, so it becomes plus 5, and then you divide by whatever number's in front of the x. So it's plus 5 divided by 2, 5 over 2. And here we negate that, so it's x is minus 4. Now, we can substitute these values back into one of these two original equations to work out what y is. So for this one, y is equal to, well, let's just put in the linear one. That's slightly easier. So we're going to do 20 minus 3 times 5 over 2. So let's do that, and that gives us 25 over 2. And let's do the same with this. When x is minus 4, we're going to have y is equal to 20 minus, so 20 minus 3 times minus 4, and that gives me 32. And there we go, we've solved it. We've got two different values of x, and for each of them we've got the corresponding y value. What about this next one, question 3? We've got x squared plus y squared is equal to 18, and we've got x minus 2y is equal to minus 3. Now do you remember that step 1 was to rearrange the linear equation to make x or y the subject. Now in this case, it's a linear equation, it doesn't have any squares in it, and we want to make x or y the subject, and neither x nor y is the subject here. So which one should we choose? Well, we have a choice, but it's easier to make x the subject here because we could easily just add 2y to both sides to get that to the other side. If we tried to make y the subject, at some point we would have to divide by that 2, and then we'd have a fraction, and it's much harder to deal with fractions. So we're going to rearrange that slightly to get x equals minus 3, and then we're going to add the 2y. So we could just write 2y minus 3, which we achieved by adding 2y to both sides. So now we've made x a subject of the linear equation, so we substitute this in to this other equation here. So we've got x squared. Now we know x is 2y minus 3, so we write 2y minus 3 squared, using brackets, plus y squared, and students often manage to miss this plus y squared, equals 18. So let's expand this out. I'm just going to do that quickly. You're going to get 4y squared minus 12y plus 9. And we've got plus y squared. And then we want 0 on one side because we're solving a quadratic equation. So we're going to minus 18 at the same time. And now let's just simplify a bit. We've got 5 lots of y squared. We've got minus the 12y here. And then we've got 9 minus 18, which is minus 9. Now we need to factorize this. So let's have 2 brackets. Now to get the 5y squared, we're probably going to have 5y and y. And then to get the minus 9, I reckon it's probably going to be 3 and minus 3. So which way works best? If I made this minus 3, that gets me down to minus 15y. And I need an extra 3y to get up to minus 12y. And that works. Look, that times to give minus 9. And then we have minus 15y plus 3y is minus 12y. And we have 5y times y, which is 5y squared. So we do the usual thing. If this bracket was 0, remember we can negate that, minus 3, and divide by that 5. So y is minus 3 over 5. And then y could also be 3. And now we've got the 2 different values of y, so we need to find the corresponding x for each of them. So let's just substitute this back into, well, why don't we use this equation here? Because we've got x in terms of y. So I'm just going to use my calculator again. So we've got 2 times y, 2 times this, 2 times minus 0.6. And then we've got minus 3. And that gives me minus 21 over 5. And this other one, when y is 3, 2 times 3 minus 3 is equal to 3. So we've got our 2 pairs of solutions. X is 3 and y is 3. Or x is minus 21 over 5 and y is minus 3 over 5. Let's do question 4. Now there's a hint here about what method we're going to have to use. It says solutions to 2 decimal places. Now that suggests that you're not going to be able to factorize whatever quadratic equation you get. And what other method do we know for solving a quadratic equation which doesn't factorize? Well, we've got the quadratic formula. So let's try this. We've got x squared plus y squared equals 9. And we've got x plus y is equal to 2. So, step 1, rearrange the linear equation to make x or y the subject. So I'm just going to arbitrarily pick y to make the subject here. So we can write y equals, now we want to get rid of that plus x, so I'm going to minus x from both sides, I get 2 minus x. So now I substitute this into the other equation. So we've got x squared plus y squared, and this is y is 2 minus x, so it's 2 minus x squared is equal to 9. So let's expand out. I'm going to get x squared plus, now you usually write the bracket out twice, but I'm going to just expand it quickly. I can do that squared. I can do 2 times that times that. 2 times 2 is 4 times minus x is minus 4x. And you do the second thing squared, which is plus x squared. So that's my quick way to expand this out. And then I'm going to minus 9 from both sides as well, so I have 0 on one side. Now let's just collect like terms. X squared plus x squared is 2x squared. I've got minus 4x. And 4 minus 9 is minus 5. Now we've got a quadratic equation which we need to factorize. But we saw earlier that it said solutions to 2 decimal places. That suggests we're not going to be able to factorize it nicely. So we're going to use the quadratic formula. We're not going to factorize it as I initially attempted to do here. Do you remember the quadratic formula was if ax squared plus bx plus c equals 0, then we can use the quadratic formula here. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's compare this to this. A is the number in front of the x squared, the coefficient of the x squared as we call it, which is 2. So I'm going to write out a is 2. B is the number in front of the x, which is minus 4, not 4. And c is this number here, which is minus 5. And let's just substitute it into this now. So we've got x is equal to minus b, so minus 4, which is plus 4, plus or minus the square root of b squared. Minus 4 squared is positive, and it's 16, minus 4 times a, which is 2, times minus 5, all over 2a, which is 4. So then I just need to put this on my calculator. I've got x is equal to 4. Now, first time we do it with the plus. So 4 plus the square root of 16 minus 4 times 2 times minus 5 all over 4, and that gives me 2 plus root 14 over 2, but I'm going to press the SD key to get 2.87 to 2 decimal places. Now the other value I can get, if I just go back and modify that plus there to a minus, I get x is minus 0.87. So now I just need to find y. Now we earlier found that y was equal to 2 minus x, so I just need to do 2 minus each of these values. So 2 minus 2.87 is equal to minus 0.87. And 2 minus minus 0.87 is 2.87. Now can you see these kind of values have swapped? And that's not really surprising, because in the original equation we could have swapped x and y and we would have had exactly the same equation. So the kind of x and y are interchangeable, if you like. Now here's a particularly difficult question that I saw in a mock paper once. But let's have a try at this kind of particularly difficult applied problem. So we've got a solid cuboid, the volume is 40 centimetres cubed, the surface area is 100 centimetres squared, and one edge has length 2 centimetres. So let's just write that all down. So one of the lengths is 2, and then we don't know the other two lengths, so let's just make them x and y. Now we're told the volume is 40 centimetres cubed, so let's try and model that. So what is the volume using our variables? Well, it would just be length times breadth times height, so it'd be 2 times x times y, and we're told that is equal to 40. Now if we divided both sides by 2, we just get xy is equal to 20. Now we're also told the surface area is 100 centimetres squared. So what is the surface area? Well, the surface area is going to be, well, we've got this surface area here, which is 2 times y, and we've got another one over here, so we've got 4y. We've also got this area here on the surface, which is x times y, but we've got another one on the other side, so we've got 2 lots of xy. And then we've also got the top and the bottom. Now the bottom is 2x and the top is 2x, so we've got 4x. And we know that total surface area is equal to 100, as we're told. And again, we could halve this to get 2y plus xy plus 2x is equal to 50. Now, we've got simultaneous equations here. We've got this equation here, and we've got this equation here. So if I label this 1 and I label this 2, it's not the case that either of them are linear, but we can still just rearrange one to make x or y the subject and substitute it into the other. So if we use 1, we can make y the subject here by dividing both sides by x. So we have y is equal to 20 over x. And that means if we can sub that into the other equation, we've got 2 times y, which is 2 times 20 over x, plus x times y. So it's x times 20 over x. And we've got plus 2x here, no substitution needed, is equal to 50. So if I simplify this, well, that's just 2 over 1, so we get 40 over x plus, well, that's x over 1 times 20 over x, that's 20x over x, which is just 20. You can see sort of that x cancels that x there, plus 2x is equal to 50. Now, I don't like fractions in an equation, so I'm going to multiply everything by x to get rid of this over x. So we get 40 plus 20x plus 2x squared is equal to 50x. Now, this looks like a quadratic equation now. So let's just get everything on one side. We're going to subtract the 50x to get 2x squared minus 30x plus 40 is equal to 0. Now, I'm going to cheat at this point and just use the quadratic solver on my calculator. So if I do that, I get x is equal to 13.5208, or x is equal to 1.4792. Now, believe it or not, we're going to get the same answer if we use either of these. So I'm just going to arbitrarily pick this one here that we're going to use. But if you use the other one, you get the same answer. So we need to find the length of the diagonal of the cuboid, which is here. Now, if you've seen my 3D Pythagoras video, you would know that you can make a right-angled triangle kind of floating in the shape here. Now let's consider the sides of this. Now if x was equal to 13.5208, we can get y by doing 20 over x. So this gives us y is equal to 20 over x, 13.5208, which is equal to 1.4792, which is actually not surprising because can you see that's the other value? So if you use x as 1.4792, you would get y is equal to 13.5208. So basically we end up with the same sides but just in a different order. So we're going to end up with the same answer anyway. So we've got y is this value here, and we've got x is equal to 13.5208. Now if we consider this triangle at the bottom here, can you see we've got a right angled triangle there where we've got the two of the sides. So we could get this third side here by just using Pythagoras on that. So we're going to do the square root of 2 squared plus 13.5208 squared, which is equal to 13.6679. So we can put this length on the diagram here, the 13.6679. And then we can finally use Pythagoras again using this triangle here with that length of 13.6679 and the other length y of 1.4792, and that allows us to finally find this hypotenuse here, out length h, which is 13.7 to 3 significant figures. Now let's finish with this test your understanding question. Here we've got x squared plus y squared equals 25, and we've got x minus y is 7. Why don't you have a go at this one? Pause the video now and we'll go through it in a sec. Right, we do step 1 first. We want to make x or y the subject of the linear equation. Let's just choose to make x the subject, so that gets us to x is equal to 7 plus y if we just add y to both sides. And then I'm going to substitute this into the other equation. So I'm going to replace x with 7 plus y. So the x gets replaced with 7 plus y squared, using brackets, plus y squared is equal to 25. Let's expand this out. So if I do it quickly, I get 49 plus 14y plus y squared. I've got another plus y squared, don't forget that. And I'm going to minus 25 so that I have 0 on the other side, because we're solving a quadratic equation, we like to have 0 on one side. Let's collect like terms. We've got 2y squared, we've got the plus 14y, and we've got 49 minus 25, which is plus 24, is 0. Now, do you remember this trick? If all the numbers are divisible by 2, we can just divide everything by 2. So y squared plus 7y plus 12 equals 0. Now, this very nicely factorizes to y plus 3 and y plus 4. So then we can either say that y is minus 3 or y is equal to minus 4. And then we just substitute each value of y back into this equation here, for example, because we've got x in terms of y. So x is equal to 7 plus minus 3, which is 4. And for this one, x is equal to 7 plus minus 4, which is 3. And we can always check that. So in the first equation, x squared plus y squared is 25. Well, 4 squared plus minus 3 squared is 16 plus 9, which is indeed 25. And is it the case that x minus y is 7? Is 4 minus 3 7? Well, yes, it is. And you can also check with the other x and y solution that we had.